And what's a rational function? A rational function is a polynomial over a polynomial. And when we have rational functions, there's three situations that we could have. Okay, so we can look, let's say n is the degree of the leading of the numerator. And let's say m is the degree of the denominator. So we have different scenarios, right? One scenario that you have is that those two numbers, those two degrees are equal. When this happens, you're going to have a vertical asymptote. I'm sorry, you're going to have a horizontal asymptote. What's another situation you could have? You could have that your m, the denominator, is actually bigger than the numerator. Okay. When you have that situation, you're going to also have a horizontal asymptote, but you're going to have a very special horizontal asymptote. You're going to have the horizontal asymptote y equal to 0. And the reason why is because the denominator is growing super fast, much faster than the numerator. So the bottom part dominates. And it's kind of like that constant over a power situation. Okay. The third situation where something interesting happens, that is, you get some sort of an asymptote, is when the degree of the numerator is exactly one more than the degree of the denominator. And when that happens, that's when you have something called a slant asymptote. They also call it an oblique asymptote. Okay. So in that case, your asymptote is going to be something like y equal to mx plus b. So these are all the different situations where you're going to have some sort of an asymptote. Either horizontal or slant. And in the other situations, it might shoot off to infinity or something like that. And it's all done by looking at the leading terms of the numerator and the denominator. So that's the big takeaway of today's lesson, is looking at the leading terms. Leading term dominates when you get very large and very negative values of x. So the third case we have is when the degree of the numerator is exactly one more than the degree of the denominator. And when that happens, you're going to have a slant asymptote. Okay. So I tried to capture that idea over here. Basically, what happens is when the degree of the numerator is exactly one more than the degree of the denominator, when you divide the polynomials, you're going to have an x plus a constant plus some remainder. So I did an example with example 4 here. The degree of the numerator is 2. The degree of the denominator is 1. Since the top has degree 1 more than the bottom, we know we're going to have a slant asymptote. I stupidly just made up some random numbers, and this resulted in a ugly looking equation of a line. So I guess the first thing you got to remember is you got to draw the little house looking thing, and the numerator goes inside the house and the denominator is outside the house here. Okay. And then how do you do the long division? You want to make sure every term is present. So you need x squared, x, and the constant. You need the same for this guy. Of course, you don't need the x squared there, but you want to make sure all the different terms are represented. And then when you do the long division, you want to kill off this leading term. So you say, what do I need to multiply 7x by in order to kill this guy off? And you got to divide by 7 to get rid of that, and then multiply by 3 to make the coefficient 3. So you multiply by 3/7 x, that's going to exactly kill it off. So you multiply by distributing, and then you got to subtract the whole thing. You still have a power of x left over. That means you can divide again. This time, if you want to kill off the 43/7, you got to multiply by 43/49. And then you'll see that when you multiply these two coefficients together, you get exactly 43/7. And when you subtract those, you get this remainder term. So now what this means is when we divide this guy, you're going to get the x term, the constant term, and then a remainder piece. So the remainder piece is just the remainder divided by the divisor. Okay. And luckily for us, this is the part that's going to go to 0 because the top is constant and the bottom has a variable. So the bottom is blowing up as the top is constant. Okay. So this was the equation of our slant asymptote right here. Does anybody have any questions about that? All right. I think you should try one. Let me ask you guys a question. Do we have a slant asymptote for number 4? Yes or no? What do you think? I agree. No. Why? Because the degree of the numerator is equal to 3. Degree of the denominator is equal to 1. 3 is not equal to 1 plus 1. So there's no slant asymptote. Okay. So the way that I would say this is, oh, this guy basically looks like x cubed over 3x, which is basically x squared over 3. I know what x squared over 3 looks like. X squared over 3 looks something like this. So we would say, as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to positive infinity. Goes up like this and up like this. Now you can do it officially by taking the limit. So maybe I should show you that. But I'll show you that after, because I want to talk about slant asymptotes. So let's take a look at example 6. Example 6, in this case, I think we will have a slant asymptote because the degree of the numerator in this case is 3. The degree of the denominator in this case is 2. 3 is equal to 2 plus 1. So we have a slant asymptote. So we're going to need to divide. So what I could do is I'd put my little house thingy here. I know that I'm going to put the numerator inside the house. There's an x cubed there. I'm going to rewrite the denominator as negative x squared plus 0x plus 4. And I do that to take care that all the different powers of x are represented. So because this is missing an x, I put a 0x there. You could also do plus 0x squared plus 0x plus 0. That's the same thing as x cubed. And now we want to do this long division. So I need to multiply this leading term, negative x squared, by something in order to get x cubed. So what should I multiply by? Any thoughts? Negative x is correct. Good, Simon and Steph. Put a negative x here. That gives me a x cubed. That's what I wanted. Then we're going to have plus 0x squared. And then we're going to have minus 4x like this. And then we're going to subtract those two polynomials. So I put parentheses, I put subtract like that so I don't confuse myself. X squared minus x squared is 0. 0x squared minus 0x squared is also 0. 0 minus negative 4x is just 4x. So I get 4x plus 0 here. Can I divide again or not? Well, in this case, I cannot. And why can I not divide again? The reason why is because this degree of this is less than the degree of this. So I'll make a comment. Can't divide anymore as the degree of the remainder is less than the degree of the divisor. Right? The degree of this is 1, the degree of this is 2. So what does this tell you? This tells you that your L of x, which was x cubed over 4 minus x squared, this is really the same thing as negative x plus 4x divided by negative, or let's write it as a 4 minus x squared like this. And this is the remainder piece. And as I've been saying before, this goes to 0 as x goes to positive or negative infinity. So the equation of our slant asymptote is, you don't write the remainder down. It's just going to be y is equal to x, and that's our answer.